Good morning, Honors Algebra 2. This is Mr. Duranko here, and today we're going to learn part of section 6.1, as you can see, graphing exponential functions. These functions are new for us. We've gone through the parabolas and the absolute value and the rational or the polynomials, and so this is new. Its parent function is y equals b to the x, where b is any number greater than 1. And these are called exponential functions. I'm going to first start out by showing you what a very simple exponential function looks like. We're going to graph it using a table, and we're going to then talk a little bit about the graph, its domain and range, if it's continuous, and things like that. So let's get started. The function we're going to look at is y equals 2 to the x. And so let's start by picking some x values. If we put 0 in for x, it's always nice to start with 0. 2 to the 0 power, anything to the 0 power is 1. And so we have the point 0, 1. If I look at 1 for x, we have 2 to the first power, which is just 2. And so that would be 1, 2. And then if we put in 2 for x, we get 2 squared, which is 4. And you can see that this is starting to grow very fast now. If I pick 3, we're going to get off the graph. It's growing so fast. So we'll stop at 2. Let's try negative values now and see what happens to the graph over here. If I put in negative 1, this becomes 2 to the negative 1, which is the same thing as 1 over 2 to the 1, or just 1 over 2, which is 1/2. And so we'll put that here, and we'll graph negative 1, 1/2, which is there. The next value that we'll plug in is negative 2. And if we put negative 2 in here for x, we'll get eventually 1 over 2 squared, which is 1/4. And so we appear to be getting closer and closer to the x-axis as we go more negative with the x values. And finally, negative 3, if I put a negative 3 in here, this just becomes 2 to the third power in the denominator, or 1 over 8. And we are getting closer and closer to the x-axis. So if we connect all of these points with a nice smooth line, we'll see that we have the function y equals 2 to the x. Its domain is all real numbers. Any x value is good, and any negative x value or negative or positive x value, they're all good, so the domain is all real numbers. The range, though, appears to be limited by the x-axis here, and so it would be all y's such that y is greater than 0. It never really touches y equals 0, which is the x-axis. That will be an asymptote. And it is a continuous function. I've connected each point with a smooth curve. It's increasing. So let me put continuous here. And it's increasing as we go left to right. And that is an example of an exponential function. And now I'd like you guys to try graphing some exponential functions. So sit tight, and I'll give you some problems to try. If you have any questions, don't hesitate to email me. Thank you.